Hello students, welcome you all to this Hello students, welcome you all to this Hello students, welcome you all to this Just let me know your feedback regarding the audio quality. Just ping me. Hello students, can you hear me? Welcome you all to this. Just check now. Sir. Welcome. I'm trying to fix this audio quality. Just let me know regarding the audio quality. Yesterday, 1.5 days, this is giving me the trouble. Hello students. Welcome you all to this. Just actually happening. So that is the reason. Anyway. Welcome. I'm trying to fix this audio quality. Just let me know regarding the audio quality. Okay. 1.5 feedback. Now, can you just check now? Just check. Welcome you all to this. Just check whether audio is improved. Anyway, my on-screen video here. Probably I'm trying to fix okay now. Audio quality. Once we set off with this audio everything, then I'll go into feedback. Now, can you just check now? I think it's okay now. Just check. Welcome you all to this. Just check whether audio is improved. Anyway, my on-screen video here. Probably I'm trying to fix okay now. Audio quality. Once we set off with this audio everything, then I'll go ask your feedback. Now, can you just check now? I think it's okay now. Just check. Welcome you all to this. Just check whether audio is improved. Anyway, my on-screen video here, as I can see, probably I'm trying to fix okay now. Audio quality. Once we set off with audio everything, then I'll go ask your feedback. Now, can you just check now? I think it's okay now. Just check. Welcome you all to this. Just check whether audio is improved. Anyway, my on-screen video, as I can see, probably desktop. Let me just reduce this. Okay. Next, video capture device. Just check now. Video capture device is okay. Just check. Video capture device, audio mixer. Video capture device, audio capture device. Audio is anyway. I'm going to mute. Just check all this now. Video capture device. Just check now. Video capture device is okay. Just check. Hello. Audio is repeating because I have not started. Something is happening. Repeating. Video capture device. Okay. I don't know. I don't know why it is repeating. Maybe because audio is repeating because I have not started. Maybe because I have opened YouTube. Okay. I don't know. Parallelly. I don't know why it is repeating. I think This is because parallelly I have opened this. Audio isn't clear and repeating. Maybe that if I shut down this YouTube video, that could be a trouble. I have muted this. Yeah. Okay. I got it. I think now I have fixed. Can you hear me properly now? Or is the audio completely muted? Can you hear me now? Can you hear me now properly? Or whether the audio is muted? Feedback is very important. If now, can you hear my voice properly? Can you hear me properly now? I have muted. Okay. Oh, great. So now audio problem is fixed, right? If this is okay now, I'll get going with the presentation. Oh, great. Thanks. Omkar, right? Okay. Fine. Can we start now? Can we start? Vishal Kulka, Venkatesh, welcome, Venkatesh. Welcome, Venki. Good. Fine. Well, friends, good morning. How are you all? Please note that there is a separate mechanism. There are two software that are being parallelly run now. One is audio video capture device, that is OBS Studio, that I am working with now. This platform is OBS platform, and I have embedded the YouTube live streaming link into this. So whatever I do, the presentations will be from this window, and it gets parallelly reflected in the YouTube. Please let me know just through your, I'm not seeing your messages regularly because I have to switch over to the Windows, okay, screens, I mean. But nevertheless, if there is any lag, there could be some minor lag, but if there is any audio issue or if you are not able to see the video, please let me know. Every time, see that you keep pinging me all the time. Keep pinging me about what you are going to see, whether the video quality is good. We may not be able to have much control on the video quality, but whether the visuals are okay, you are able to see the screen and able to hear my lectures. Yes, good. Venkatesh Kulkarni, you mentioned that the problem is fixed. Meg Shubalkar, welcome Meg. Looks good. Are you excited to be for part of this online streaming video lecture? I suppose so. A lot of efforts have been put by me in last say 4 to 5 days in understanding this whole setup, but nevertheless, all is well that ends well. So I would like to start today's class. I'm just waiting for a few other of your friends to join. Meanwhile, let me know how are the things at your end. Hope you are taking care of your health. Hope you are one sec, because yeah, see that follow the rules, regulations and quarantine policies. Stay at home, don't move around no matter what the compulsions may be, and see that strict lockdown is being observed. I have been doing that nevertheless, no matter what. We have been very much stationed here or inside the house, so it is extended. It is in our own benefit that we are trying to do this, but I like this has given a wonderful opportunity. Really, I take it a positive step that I needed to learn something new. Always this was in my mind, to start something with which I can get connected to the students, both live as well as through video platforms, through through online video lectures. You must have seen my 2-3 lectures that I have uploaded. Initially the first video was a bit difficult for me. I couldn't switch over the windows that effortlessly. Second one was better, but the audio quality was poor. Third one was also, yesterday I got a feedback. It is a 1 hour video that I have uploaded. There also the audio quality was poor. This was primarily because there are many complexities for fixing each of these, and probably it is only the learning experience. It is a practice and only the practice. So keep trial error, note down the videos, record the videos, play them, identify the fault. Then of course there are YouTube videos on how to create online streaming lectures, but unless you go ahead with actual lecturing, or you go ahead with one content, you try developing one content and then go on to the recording and then live streaming, you will not come to know. Believe me, till 9:55 since yesterday I was not able to fix this. 9:30 maybe 9:45 I was unable to fix this audio problem. Even after starting this, I think there was some audio issue. Unless I get the feedback, it is very difficult. So the mistake was happening that I was switching over between the recording software as well as the YouTube, and on YouTube the volume was on, and that is where the audio disturbance was coming. Now I think, yeah, Venkatesh, good. How many? 4 people have joined. Meg, Venkatesh, then I don't know who other 2, maybe one is myself and another one I don't know. Omkar, yes, Omkar is another guy. Please circulate this now. Just ask your friends quickly to join me online, so that it will be an interactive session. As you can see, my typing is relatively fast. Typing is reasonably fast. I can respond to your queries immediately. Okay, I have not yet started the lecture. I'm just waiting for other students to join, so that it is beneficial to all. Okay, meanwhile I'm just telling you what all is the plan. Yeah, this lockdown period has given us the wonderful opportunity to learn new things. Take it in the positive sense. Positive side, try to learn new software, try to understand the subjects. We have uploaded, all other faculty have uploaded good number of their PDF files, their video lectures, then the lectures that were held in the class that have been uploaded. It is a challenge to go for online lectures. Please note what are the challenges. Okay, easiest way is for YouTube video streaming is just one sec. Just please excuse. Sorry, there is some minor hiccup. Okay, please understand what are the challenges faced during, so that once other students join I can start the actual lecture. But let us understand how this live streaming goes, or what are the intricacies. Going directly online live streaming with one single face, that is, you are seeing my faculty giving you the lecture, it is relatively easy. Now I am going to speak continuously for 1 hour, but I cannot show you the PDF. Something like, I will have to hold this before you, some drawing or photograph or some such thing, and it may not be very clear. It looks so unprofessional. This looks so unprofessional. So this is one way. Of course, this is one way. If with a single camera, if you want to do, you can always, but it is very difficult to manage the show here. You will have to hold it in this, and it looks very primitive. Got it? Okay, so that is one. Then what is the next best way? You need to install some software which will have what is called as a streaming key. So you will have to acquire that streaming key from YouTube video here. Of course, you people are all more highly knowledgeable in these matters, no doubt, I know. but some of you may not have experienced or you may not have tested this. Nevertheless, I tried using this OBS software. Okay. Next, as you must have seen in my yesterday's video, I have tried to show you the on one media file. I have tried to show you the PDF file. I have tried to show you the solution to the numerical that I discussed yesterday on limits, fits and tolerances. I have showed you all those, and all the time you were able to see my video. That exactly was my plan when I started. But still, till yesterday, the audio problem was persisting. I tried my level best. I was unable to fix that in spite of going through so many videos, YouTube videos, online videos, nothing. But nevertheless, I think now we are today, fortunately, all the problems got fixed. Respond, I can, yeah, still, oh good, two more have joined the discussions now. Who are those? Just introduce yourselves, please. Introduce yourselves. Those who came, those who are online now, those who joined the live stream. Yeah, those will join just now. Sir, audio is fluctuating. Harshit. Great. You have joined live stream, is it? Great. Then who are the other people? Audio is fluctuating. I have tried my level best. Probably nothing much I can do. Are you able to hear me properly? Are you? See, I have muted YouTube, so I will not understand if I am audible. Unless you give the feedback. Through message. Yeah, I have muted. Okay, good. Who is this? Newly joined? Chetan Kumar, Hebballi. Good morning. Good morning, Chetan. So how are the things going? So as I can see, 8 have joined. Who is this new? Sir, it is repeating a bit. Rohin Lengde. Oh, great. Hello, sir. There seems to be a lag in the audio video. True. Lag in the audio video. Primarily because what I know. The lag is because the YouTube streaming video is so capturing device is one software. This in turn sends the signal to YouTube streaming channel and then it gets uploaded. So this is the lag that is happening. Probably next time when I come online, I'll straight away go use YouTube channel's online service. That I think looks better, but that is an inherent advantage. There I'll not be able to showcase you the PDF files that I'm planning. Okay, now have a look. What I want to show now is this. Can you see the PDF file now? This is exactly not possible if I go use direct YouTube streaming. Can you see the PDF file? Yes? Can you see? Can you see the PDF file? Does anyone have any information how to fix the lag problem? Streaming is healthy. Okay. How to fix the lag? Oh, great. so you are able to see the PDF file. Okay, good. Next, I'm just checking all these settings. I'll just open up one my drawing. I would like to live stream that as well. Just check and let me know your whether you are able to see the drawing sheet. Okay, can you see the drawing? Let me increase its size. Please don't worry about the alignment, that I can fix. Okay, can you see this properly? I can reduce my size. I can increase the drawing size. All these are initial setups that I am planning to do, so that once I start my lecture, you will be able to see the drawing sheets and associated discussions. What happens is, live streaming always there is a difficulty of lag because of the bandwidth, speed, and many factors associated. But once this live streaming gets over, probably it gets recorded, and then that will be uploaded onto YouTube. So there again, you should be able to fix. You should be able to hear it, all the audio videos properly, right? Okay. Can you see this drawing file now? Can anybody message? Yes. PDF is not visible. I think it's visible. Now I have opened the drawing, not the PDF. Can you see the drawing? PDF I can make it open. Just all the two, three things I'm just shuffling. PDF file, myself, along with the drawing. Once everything is fixed, I will start gradually the lecture. How many have joined? 9 have joined. Who is the latest person? Chetan, yeah, Meg. I think one more has joined just now. Well, friends, fine. Please bear with the lag. Please bear with lag of audio and video. Okay. I have tried a lot to fix all associated problems, but some things are beyond our control, are beyond my limits. Okay. Nevertheless, okay, fine. So everything is set. My video is seen, PDF is seen, drawing is seen. We will start. Well, friends, welcome you. Welcome you to my session on limits, fits, and tolerances. Great. Okay. In today's lecture, I'm going to discuss completely about entire system of limits, fits, tolerances, and gauges. Go through my videos also, but the main importance of today's the focus point of today is how to solve the numerical. Right? I would like to solve one problem associated with limits, fits, and tolerance, and continue the same problem for gauge design. If you come across any difficulty while discussions, you can go back to my video. Systematically it has been solved. You should be able to get the understanding, and of course once the you can live session chat line is on all the time. You can pose the question. I'll respond to that. That's not a problem. Maybe even later also I can do that. Okay. Now Unit 2, systems of limits, fits, tolerances, and gauging. Definition of the topics that we have is definition of tolerance, principle of interchangeability, selective assembly, concept of limits of size, tolerances, compound tolerances, accumulation of tolerance, definition of fits, types of fits, geometrical tolerance and positional tolerances, hole-based system, shaft-based system, classification of gauges, concept of design of gauges, Taylor. We need to discuss about Taylor's principle, wear allowance of gauges, then types of gauges, plain gauge, ring gauge, snap gauge, and of course we need to understand what are the gauge materials and what are the precautions we need. Of course, this is one of the most important mechanical engineering topics which we need to take it right up till our shop floor practice, or in practical engineering. Once we enter the main field, once we get to the manufacturing stream, especially knowledge of limits, fits, tolerances, gauging, how to solve surface finish, and the methodologies to measure all this and understand the concepts is extremely important. Even for designing, we need to understand what are the allowed limits, what are the tolerances, what are IT grades. All these things we need to know. So there is a though it is scheduled for 10 hours, I think much of it is theoretical, which I have much of it I have uploaded in my PDF file. You can download that PDF file. I think you must have done it anyway. If not, please download that. I will quickly go through the initial steps, and my focus more will be on numerical. Let us understand the numerical clearly without any without any doubt in our minds. And I have developed over a period of time a systematic methodology to solve this limits, fits, and tolerance along with the gauge. Okay, let's get going. Let me see what are the number of people. Only 7 now. Some 2 have left. Mahendra Anvekar. Hi. Welcome, Mahendra. Okay, good. I think you are already aware about selective assembly. We are aware about concepts of advantages of interchangeability. All this was discussed in the class anyway earlier, and in my previous class also. Okay. Let us know the basics. Let us understand the basics of this. One is this is the whole shaft, and here is the hole. Then tolerance. This part is called as a tolerance. The difference between the maximum and the minimum limit of a shaft or a hole is called as a allowable tolerance. Gauge tolerance is 10% of the shaft or the hole tolerance. Please note this. In the examination, normally it is mentioned as gauge tolerance is given as 10%. If not, you should know it. Next, this is the zero line. You can observe zero line or zero deviation, and the XY line we call it as the basic size, below which, if it is a shaft from A to H shaft, we need to understand the shaft terminologies and the whole terminologies. Let me show this. I think there is some gap, right? Please bear with that. Okay. Okay. Let me straight away jump to, rather than going through the basics, go to the problem. Okay. Yes, this is most important. As you can see, A to H shafts, the shaft nomenclature is designated in terms of capital A, 45, E8, E7. E is a hole, small e is a shaft, and 8 is the IT grade, 7 is the IT grade, which corresponds to some IT tolerance value. Those are already defined. I will show you later. Next, A to H shafts, which are above XY line of the basic size, and then A to H shaft, A to H shafts are below XY, A to H holes are above XY. Can you see this? And once you cross H, you come across J, K. There is no I shaft and I hole, because I indicates tolerance. Next, you have M, N, O, P, Q right up till Z, A, Z, B, Z, C. These are the hole sizes, and then you have Z, A. These are negative tolerances. These are positive tolerances. Okay. Next, IT grades. IT grades start from IT01 to IT1, IT01, IT0, IT1, IT. Please note, IT01 is different from IT1. IT1, IT5, IT6, right up till IT10, IT16. And if somebody asks you in the examination what kind of finish that one may get, or what is the tolerance that could be given for turning, we should be able to tell somewhere in the range of IT7, IT8 or IT9. We should never tell that turning will give the tolerance zone of 15 or 16. The IT 16 is the highest tolerance which is given for the most primitive kind of manufacturing, that is sand casting. IT 15, again it is rough, it is a die casting process. Of course now the improvisations have taken and the tolerance levels have come down drastically, but nevertheless the tolerances expected out of die casting stamping is around 15. IT 15, 12, 13, 14 represent metal forming processes. IT 11 represents drilling, rough turning. IT 10, yes, milling, slotting, planing, rolling, extrusion. IT 8 could be for your turning, boring and reaming. Then IT 7, as you move towards IT 7, 6, these are all precision machining with very precise tolerances, very less. The tolerance runs in the range of 0.001 mm, or we say 1 micron, 2 microns, 10 microns, 20 microns. So these are the kind of finish that we are expecting. And for gauges, we go to the fourth decimal, that is 1/10 of a micron, 0.1 micron, 0.01 micron. We go to that extent. So we should have a knowledge of the 0.001 mm is the tolerance. 0.0001 for that 10% of that tolerance is gauge allowance. So 0.0001, the gauge is increased or decreased only by the size of 0.001 mm. Okay. Next, IT1 to IT5, superfine finish processes. These are used for gauges, manufacture of gauges. IT6 is normally achieved by grinding. Next comes super finishing processes like lapping, diamond boring, etc. So IT01, IT0, super finishing machines. These are manufactured by using super finishing machines. Let me just check what is the feedback because I am into another window. Let me go back to YouTube window and then see how many have joined. Only 3. One more is joined now. Mahendra. Okay, no, someone Mahendra and Maker. One new person has joined. I don't know who is that. Okay, nevertheless. Next, quickly going on to the problem. Basic size, all these are, we know them well. Minimum size, maximum size, this has been discussed. Okay. One more thing, deviation. Maximum hole size minus basic size is upper deviation. Maximum shaft size minus basic size is upper deviation. In this case, can you say what is upper deviation and lower deviation? See, this is 0 line, this is minimum size, this is maximum size. So difference between maximum and minimum size is the net deviation. Can you tolerance here? This is the hole size, this is the shaft size. So this is minimum shaft size, this is maximum hole size. In between is nothing but maximum tolerance allowable. Kind of the total tolerance between the hole and the shaft. Minimum tolerance between the hole and the shaft is maximum size of the shaft and the minimum size of the hole. Okay. One more important fits. This is hole based system and shaft based system. Basic hole based system, this is basic shaft based system where hole size is fixed, shaft size keeps on changing. This is basic shaft based system. Basic hole based system, in this the 0 line, the clearance fits, transition fits. As you can see, the hole size, the basic hole size system indicates 3 types of fits. One is transition fit, clearance fit and interference fits. Okay. Here comes one important table. Let us know all this about what is called as, just a minute, fundamental deviation. Fundamental deviation is the distance between the mean line or the basic size to the minimum deviation of the hole or the minimum deviation of the shaft. This is called as a fundamental deviation. As you can observe, each hole and each shaft, there is no fundamental deviation. That means they are exactly on basic size. One of the basic limits of H hole and H shaft is always 0. Then you have H7, H8, H9. These are IT tolerances. That's your other limit, higher limit for the shaft, hole, and then lower limit for the shaft. Okay. And for same class of shaft and the hole, suppose in D shaft and a D hole, the formula for fundamental deviation will remain the same, minus 16d to the power 0.44. See, G, for G shaft and G hole, hole designation, only the sign changes. G shaft is below XY line, G hole is above XY line. A to H hole and A to H shaft. So the deviation is positive here, deviation is negative. Once you cross H, for shaft you start getting a, look at this, for shafts you start getting positive deviations, for holes you start getting negative deviation, right? So once you cross H, what happens is, there is no I, J, K, L, M, N, O, P, right up till Z, these are on the positive side, so the deviation is positive. Shafts on the positive side, so the deviation is positive. For holes, A to H, positive deviation, and then once you cross H, then you have K, L, M, N, these are below basic size, these are negative deviation. And the formula will remain the same. We need to understand E, F, G, H, 11d to the power 0.41, 5.5d to the power 0.4, 99% you will normally you will have given with in the examination. The examiner will give you the fundamental deviation formula. You may not be expected to know, but at least you should know that H hole fundamental deviation is 0. Okay, then with this, let one more important concept. Tolerance I is equal to 0.45 cube root of D plus 0.001 D. Okay, and in D, in order to calculate D, we need to understand what is D1 and D2. D is nominal diameter, which is nothing but the mean of D1 and D2, where D1 and D2 are diametral steps. Standard diametral steps are 1 to 3, 3 to 6, 6 to 10, 10 to 18, 18 to 30, 30 to 50, 50 to 80, 80 to 120, 120 to 150. Yes, you need to by heart this. Normally it is not given in the examination, but sometimes they do give. But students are expected to know the basic diametral steps of at least say 80. So it is relatively easy. 1 to 3, 3 to 6, 6 to 10, 10 to 18, 18 to 30. Okay. Then these are IT grades. For IT grades, IT5, IT6, IT7, IT8, you have right up till IT16, and these are the tolerance values, 7i, 10i, 16i. We need to know at least some 3 or 4 tolerances. IT5, IT6, IT7, IT8, IT9, these are normally being used in our limits, fits and tolerances. So we should know this. IT6 corresponds to 10i, IT7 corresponds to 16i, IT8 corresponds to 25i, IT9 corresponds to 40i. Yeah, I can see Pratik Singh Nargundkar. Hello Pratik. How are you? Now, just a minute. A quick feedback. How is the session going on? Are you people able to view the lecture properly? My question basically is it worthwhile to live stream this lecture? Are you people able to view the lecture properly? My question basically, is it good? Based on your feedback, I can continue. The session further. Yeah, session is going on smoothly, but with some audio disturbance. That's okay. It is quite likely to happen. Fixing everything is very, very difficult. You please note that you have the bandwidth issue, you have the lag issue, and I am toggling between two software from one to another. Okay, there is kind of lag, I agree. In that case, all you need to do is just minimum. Oh, it is very difficult for you. Nevertheless, I will try to minimize my video also still further, so that you can see the PDF file better. I'll just take it to one corner. Just check now. I will decrease the size. I think this looks good, right? Now can you see the PDF file completely in one stretch? I think it should be good, right? Okay, thanks for your feedback. Harshit, worth watching, sir. Thanks, Harshit. Let me continue with the positive. Yes, session is smooth. Good. Madhuram, Mantri. Hi, Madhuram. Great to experience this new methodology. Okay, great. Fine. 9 people have joined and 1 has liked. That thanks for the like that I see here. It gives, what happens is these kind of the new experiments that we do. Initially, please note, always anything connected with hardware, software, and then live streaming, or for that matter learning any new subject, or especially the CAD/CAM software that you want to learn, unless you work a lot, once you it is very difficult for you to overcome the difficulties. But once you understand the difficulty levels and fix the problems, I think we should be able to further, it will be much easier for us. But I am in a learning phase now with regard to live streaming. Now let me continue with my lecture. Yeah, coming back to the PDF file. Yes, so please note, IT5, it is better that I request you people to have a pen and a pencil or a paper in your hand, so that once I start solving the problem, I'll give you 5 minutes, 2 minutes time. You can work on that. Hold your laptop, hold your laptops, and then maybe, or the mobiles, whichever device you're using, and a pen and a paper. I'll give you 2 minutes, 3 minutes time. Meanwhile, I can chat online, and I want this to be exactly like a classroom session, if it is okay for you. Otherwise it becomes boring for you to hear only me giving the lecture, and numericals cannot be taught by oral presentations. You need to solve it. I will tell you, I have solved the problem. Okay, just follow the steps. Okay, now I have not yet started the numerical, I'm just giving you the background. Okay, so value in microns, IT5, IT6, IT7, IT8, these are right up till IT16. Normally for our examinations we will get the values of, say, H7, H7D8, or ABCD, maybe F hole, or G hole and a F shaft, G hole. These are all clearance fits. So G hole, say G5 and H, G5 and G5 E5. What does it mean? G hole with IT grade as IT5. And if say IT5, the tolerance is 7i, and we already found out I value here. I is equal to 0.45 cube root of D. And what is this D? D is nothing but root of D1 and D2. And please note the dimensions and the units. D1 and D2 are in millimeters, and the I value that you get here is in microns. You have to substitute the value of D in millimeters. I will show you in the numerical how it is being done, right? Okay. The only mistake that students tend to do here is interchanging the units, which entirely messes up the whole numerical. Okay, forget about all this. We will go ahead with the solution. Fine. Okay, and in my PDF file I have solved, but I will show you here through my drawing now. Let us get going with the drawing, and I will reach right up till limits, fits, and gauges. Okay. Please give me one moment. Okay, 1, 2. Just give me a time. Okay, all set. Fine. Sorry for interruption. Okay, now friends, can you see this drawing sheet now? Okay, can you see this? Can you see this now? Is it visible? Is it visible? Can you see the drawing sheet? Oh, great. Okay, fine. So now let us analyze the given problem. Okay. The problem states design go and no go gauge for the 25H7F8 shaft. Can you see this? 25H7 and F8. Okay. First, let us understand what the given problem is, and then we will be able to give the solution. First, for understanding the problem is 50% of the solution. Let me write it here for better understanding. Given numerical says, and almost all the numericals will be of this type. Okay. Says 25H7 F8, right? Okay. 25H7 F8. So this is the given numerical wherein we need to design the gauges. Okay. Design of gauge has two components. Design of gauge has two components. You need to divide this problem into two parts. Okay. One is gauge design, obviously. One is gauge design. But primarily you need to find out the limits and the limits, fits and tolerances for 25H7 and F8. This completes your 50% of the problem, and gauge design consists your remaining 50% of the problem. Understood? 50% of the problem is initial limits, fits and tolerance. Another 50% is gauge design. Okay. Let me again tell you the number of steps here. What are the things that is to be discussed? First, always solve the problem using a drawing sheet. Okay. I don't know if this, okay. Drawing, a simple drawing, rough drawing. Okay. Let us understand 25H7 F8. I'm trying to fix the camera. Wait. I think now the zoom is okay. Okay. Can you see this now? Zoom looks okay, right? Just check. Thanks, Chetan. Okay, good. So continue. Let us continue with our discussion. Done. So now come back to what we have to find out. We need to understand here, follow the steps. 25H7F8, we need, I said, na, we need to solve, we need to identify the limits percent tolerance for the hole, for the shaft, and then go for gauge design. Okay, now draw the sketch. Look, H7 hole. H7 hole always is on XY line or basic size. This is basic size. Okay, so this is IT7 because H7 IT7. IT7 corresponds to 16i maybe. IT7 corresponds to how much is that? Just check. IT7 is already given in the problem. IT7 is 16i. Can you see this? IT7 is 16i. It's already given. All this data is given. Given data. So IT7 is 16i. Right? We'll understand I, not a problem. Now, here I need to, the two things that I need to calculate are, this is 25, basic size, 25 mm. Next, only one I have to identify, second value. This is minimum size of the shaft, minimum size, sorry, hole, minimum size of the hole. This is maximum size of the hole. Maximum size of the hole. Okay. I need to identify, this is number 1, this is number 2. We have to identify these two values for hole. Two values for hole. Beginning. Next. We need to similarly find out two values for shaft. Okay. Same thing for shaft. And what is the shaft? Shaft is 25F8. 25F8. So first is hole design. Next is shaft design. Shaft design. Okay. 25F8. What does 25F8 means? F shaft lies below XY line. This is F8. This is IT8. Right? This is IT8. Can you see this? Okay. We need to, for this shaft, we need to understand two values. Minimum value, this is maximum value of the shaft, maximum size of the shaft. This is basic size, maximum size of the shaft. This is minimum size of the shaft. This one. Okay. So we need to identify number 3, number 4. So please note 1, 2, 3, 4. I repeat 1, 2 values of whole, next 3 and 4, third and the fourth. Third is minimum size, fourth is maximum size. Okay, with this let us continue with our numerical. Please hold the paper. Okay, now look at this. First step, I am solving this step by step. Step 1, d is equal to root of 18 into 30. How did you get 18 into 30? That is standard diameter step 1830. Clear? It's already given, and if not, you need to remember this. Not necessary that the diametral step will be given. And one more important point here, if the diametral step is supposing 30, if this diametral step is supposing 18, then which step we need to take? We need to consider the previous step. If it is 30, we need to take 18 to 30, not 30 to 50. The next diameter step is 30 to 50, but we should not consider. If the diameter value, supposing if the problem given is 50H7F8, 50H7F8, in that case, we need to take the diameter step as 30 to 50 and not 50 to 80. Please keep this in mind, otherwise the entire numerical will go wrong. You got it? Okay. Now, 18 into 30, this should give you 23.2. One sec, let me check the streaming if it's okay. Because every time I need to check, go back to this. Thanks Chetan for feedback. Okay, there are only 5 connected viewers now. 5 connected viewers. I expected more viewers, more students from for Sem class. Nevertheless, they may view this video again. Okay, good. Now, coming back to the solution. Thanks, Harshit. By the way, I don't know, you have joined this live streaming. Quite interesting. Thank you so much. If you have got any inputs, you can always ping me. You can just message. I will read out for that. I can share that as well. Okay. Now, please note 2 important things here. One, where the mistakes is likely to happen. D value should be in millimeters. While finding out the tolerance, D value is in millimeters. D value is in millimeters, and I what you get here, I have already mentioned as microns, 0.45 cube root of D, 0.001 D. Okay. Please note step 2, 0.45 cube root of 23.2 plus 0.001 D, 0.001 into 23.2. That becomes, you get the answer in 1.307 as the micron. It is not mm. So that equals 0.00130 mm, approximated to 0.001 mm. Okay. Now, 2 steps. Step 1, step 2 is over. Let us follow the step 3. Just a minute. Can you check the stream? I'm just, I got a message from VK saying that some students are finding it difficult. There is some loop happening. I don't know. Maybe they have confused with the previous link. They need to use this link, the present streaming link. You can, in your friends groups, please check what is to be done for this. Pass on this streaming link to your friends. Some students want to join. As I got a message here, from Professor VK Kulkarni, Vinay Kulkarni, I think the students are finding some issues. Nevertheless, Vivek Tiwari is Boli. Vivek. Yeah, continuing with my problem on hole design. Okay, so fundamental deviation. Now step 1 is over, step 2 is over. Step 3, fundamental deviation. Okay, and I have drawn the sketch. Simple. Try to draw the sketch and solve the problem. It is much mechanical way, system, simple way, no complex integration, differentiation, calculation of formula or anything. It is just addition of plus, minus, some value here and then. That's it, nothing more. The mistake is occurring only while while converting from micron to millimeter or millimeter to micron. Nothing more than that. Okay, step 3. Fundamental deviation for H hole. H is 7. H hole is fundamental deviation is 0. Can you see this? Fundamental deviation is 0 and it is IT7. And please note, IT7 is given as 69. It's already given. We are not finding out anything. So IT7 is 69 and I value, if you substitute in millimeters, you get here in millimeters. If you substitute this in microns, this will be in microns, convert into millimeters. 0.021 mm. Therefore, the whole size is, please note, one is 25, already we know, basic size. Another is 25 plus this IT7, that is equal to 69. I have already mentioned 0.021 mm. Can you see this? 0.021. Therefore, the two values of hole are 25 plus 20 and 25.021. Hole is over. Hole number 1, number 2 is calculated. Shaft design. Because of the time limitation, I would like to move fast bit here. Later on you can again retrieve this video and then go through the contents. I have uploaded this separately. Please look into that. Shaft design. Please look, draw the shaft. Shaft is F8 shaft. Obviously it is below XY line. Fundamental deviation. Fundamental deviation for F shaft, can you see? Minus 5.5 raised to 0.41 in microns. And why minus 5.5? Because this is F shaft. F shaft lies below the basic size line. Can you see this? So this is the basic size. Sorry, this is the basic size. This is F8 and meanwhile, okay, let me complete this. I will tell you. F8. These are the two values that we need to find out. One is the higher maximum size of the shaft. This is minimum size. So shaft is moving from this end to this end, right? This is central part. This is the maximum size. This is the basic size, 25 mm. And obviously F shaft means it is less than the highest size, less than the maximum size with a fundamental deviation of 0.020. How did you get 0.20? This minus 5.5 d to the power 0.41 in microns, where d is again in millimeters. Please substitute d value in millimeters and don't confuse with basic size. This is nominal size. This size is nominal size. And what you get here is microns. 19.96 micron. That is nothing but 0.019 millimeter, 0.01996 mm, or I have rounded it off to this is also rounded off to 20 microns, that is 0.020 mm. Is there any difficulty? I don't think. 020. So far so good. Next, tolerance for shaft. Please look into the drawing, fill the data straight away. Fundamental deviation we know 0.020, fine. Next, tolerance value we have found out how much is the tolerance? IT8. Can you see? IT8 is nothing but 25i. 25i is nothing but 25 into 0.001. I value is substituted in terms of mm. So I get straight away 0.032 mm. So shaft size now. Fundamental deviation 0.020. Next, tolerance is 0.032 mm. So maximum size shaft size is 24.98. How did you get 24.98? 25. This is 25 minus 020. Fundamental deviation 020. Next, tolerance. Tolerance is 032 mm. So number 3, number 4. 3 is 24.98. Then D is this, so number 4. This one is 25 minus this minus this. That becomes 24.948. Please check this. Okay, I think this live streaming is going on since 1 hour 16 minutes. This is first half of the numerical. Next half I would like to take up by tomorrow 10 o'clock. I don't want to stress you people with a lot of material as on now. Tomorrow same time 10 to 11. Please keep your friends informed about the next subsequent. I will just repeat this tomorrow once again, and then quick recap of this problem, and then we will go ahead with gauge design. Mind you, this is one of the most important topics for your IAs, for your examination, for your future, for your shop floor activities, shop floor manufacturing. We need to have a basic knowledge of limits, fits and tolerances. Okay, now a quick review. We have been asked to find out design the gauges for 25H7F8. What we have to find out, we should find out 4 values of the shaft and the hole, 2 values for the hole, minimum size of the hole, maximum size of the hole. Next, 2 sizes of the shaft, minimum size of the shaft, maximum size of the shaft. This completes your 50% of the problem. Another 50% is gauge design, that I will discuss tomorrow. In a gauge, you have to identify 8 values. 8 values. 4 values for hole and 4 values for shaft. In 4 values, 2 values for go and no go gauge, go gauge for 2 values for hole, no go gauge for hole, 2 values. Next, go gauge for shaft, 2 values, then no go gauge, 2 values for hole. Okay, we'll continue this. Let me just check how many have. There are hardly 4 now. Nevertheless, thanks. Thank you all for joining this live streaming. Please let me know your views. I have already expressed. It is a wonderful experience for me to be with you. Of course, I do understand the system lags, video lags, all those are happening, but though I don't have any control on those. Whatever control I was able to do, I have tried my level best. I would like to, and tomorrow one more thing could be done. Instead of presentation this way, I can straight away go live completely from one end, but there I will not be able to showcase you. One more thing, please note, I am quite excited to show you the setups that I have done for this live streaming. Can you see this? This is the webcam that I am using. Can you see this? Okay, and this is how the drawing sheet is placed. Can you see? Okay, so the parallelly 2 devices, and then of course I'm also using this window, see, PDF file. Then I'm able to move. It is quite an exciting exercise for me. I hope you enjoy this methodology. Right? Can you see this? And then I have made yeah, one more is some arrangements. Okay, thank you friends. Thanks a lot for your patience, patient hearing here. Your time. Tomorrow I look forward at 10 o'clock sharp. Let us get going with the next session on gauge design. Please bear with the limitations of technology that we face, or the bandwidth and audio and poor. Yeah, it happens, but hopefully by tomorrow I should be able to come out with a better presentation. Thank you. Take care. Be safe. Have a wonderful day. Thank you.